This project aims to compare decision tree and random forest-based learners in analyzing Formula One race data, predicting race results, and predicting the 2025 Drivers and Constructors Champions. The data I've gathered from Kaggle to do so contains driver profiles, circuit information, race statuses such as finished or accident, and race data from 1950 to 2024. From this, I've parsed the data into 38 criteria shown on your screen that I'll use to make predictions. The parsed data is shown in Appendix A, so it's lights out and away we go. Here is a decision tree from Appendix C mapping Formula One data to a predicted race start. A decision tree is a tree-based learner used in this case for regression. This regression tree initially contains all the data from every category, then splits the data recursively into smaller subsets based on a cost function to determine the best criteria, minimizing variance. The function I'm using here is mean squared error, elaborated on in Appendix B. Once these split points are created, leaf nodes of many criteria are created, with an average value becoming its predicted value. When multiple criteria are present, such as in this example of F1 qualifying results, an additional function is needed to determine relative importances. For this case, it's the Gini importance function. However, future investigations may use polynomial regression times individual weights to determine the results. A random forest is a more widely used form of tree-based learner than a decision tree, as the random forest combines all the data and cross-validates it. After this, each tree donates a random portion of data for training and tuning, then determines split points from decision trees generated from this data. After this, these predictions are then aggregated to form a final regression, using a similar cost function to the decision tree. An example of one of these random forests using the F1 data is shown on your screen and is found on Appendix D. For each of a sprint qualifying, sprint race, Grand Prix qualifying, and Grand Prix race, I've simulated a model for a decision tree and a random forest. Once these models are generated, I simulate qualifying to obtain starting positions to input into the race function. Then, I simulate the race. Before that, if the weekend has a sprint race, I use the sprint models to do the same thing. After I simulate every race, I aggregate the points and determine a Drivers and Constructors Champion. The decision tree-based simulation determined that Oscar Piastri will be champion with his McLaren team winning the Constructors title. The random forest-based simulation determined that Lewis Hamilton will be champion with his Ferrari team taking the Constructors title. Based on data in Appendix B, the average mean squared error for a tree-based learner here is 52.67, while the average for a forest-based learner is 34.62. Additionally, graphs from Appendix E show that race start, driver experience, and constructor experience is the most important factors. Therefore, between two tree-based learners, the random forest will be more accurate. Future investigations may examine other machine learning features such as polynomial regression and k-means clustering to investigate.